now let's start with decomposition reactions. Here we have an activity once again. Take about 2 grams of ferrous sulfate, that is FeSO4 crystals, in a dry boiling tube. This is a boiling tube. Take FeSO4 crystals into it. Note the color of the ferrous sulfate crystals. Okay. Know the color of them. Heat the boiling tube over the flame of a burner or spirit lamp as shown. Observe the color of the crystals after heating. Okay. If you observe this figure carefully, here you could find a test tube with the help of a tongs over there. Now, take a boiling tube, add some ferrous sulfate crystals, observe the color before the reaction and after the reaction. This is a burner. They gave some instructions here. Do not point the mouth of the boiling tube at your neighbors or at yourself because the flames that are coming outside this is very dangerous. Have you noticed that the green color of the ferrous sulfate crystals has changed? You can also smell the characteristic odor of the burning sulfur. Okay, now this is a reaction. First, let's decide whether it is a combination reaction or not. How many reactants we have? One reactant. How many products we got? Almost around 3 products. Is it a combination reaction? No, it is not a combination reaction. So what is a combination reaction? If 2 or more than reactants combine to give us a single product, we call it as a combination reaction. Clear? Now let's classify what type of reaction is this. This is what the reaction that took place from the activity that we performed. In this reaction, you can observe that a single reactant breaks down to give simpler products. This is a decomposition reaction. Ferrous sulfate crystals, that is FeSO4.7H2O, it's dot, not comma, it's dot, lose water when heated and the color of the crystal changes. It then decomposes to ferric oxide, sulfur dioxide and sulfur trioxide. Ferric oxide is a solid while SO2 and SO3 are gases. If you see here, one reactant is getting decomposed into 3 various products. It might be 3 or it might be 2. So it is called a decomposition reaction. That is, a single reactant is breaking down into 2 or more products. This type of reaction is called a decomposition reaction. Clear? Now, if you see the physical states, FeSO4 is a solid, but SO2 and SO3 are gases. Decomposition of calcium carbonate. This reaction is a very familiar reaction for us, right? CaCO3 gives rise to CaO plus CO2. Of calcium carbonate to calcium oxide and carbon dioxide on heating is an important decomposition reaction used in various industries. Calcium oxide is called a quicklime. It has many uses. One of is the manufacture of cement. When a decomposition reaction is carried out by heating, it is called a thermal decomposition. If you have heat, if heat is provided in order to make the reaction, in order to proceed the reaction, then you call it as a thermal decomposition. Here, one reactant breaking down into 2 products. A single reactant will break down into 2 or more products, and this type of reaction is called to be a decomposition reaction. If heat is associated with the reaction, then you call this as a thermal decomposition reaction. Let's look after another reaction as well, a thermal decomposition one. Take 2 grams of lead nitrate in a boiling tube. Hold the boiling tube with a pair of tongs and heat it over a flame. Now, what we have in this? We have lead nitrate. Now we are taking the case of a lead nitrate. You will observe that the emission of the brown fumes. These fumes are nitrogen dioxide. The reaction that took place over here is 2 PbNO3 taken twice. In the presence of heat, 2 PbO plus 4 NO2 plus oxygen. Here the physical states are clearly mentioned so that we get more information from the reaction. So one reactant breaking down into 3 products, which is nothing but a decomposition reaction. And this decomposition reaction took place in the presence of heat and it is carried out by the heat. So it is a thermal decomposition reaction. Now, we have these activities, that is 1.7 and 1.8, to know about decomposition reactions in a clear manner. Now, this activity is nothing but the process of electrolysis of water. So in this process you will find a mug. In that mug place some water. Later place two test tubes containing two electrodes made of graphite. Connect one with the positive terminal of the battery and the other with the negative terminal, one with anode and one with cathode. Connect all these two connecting wires, one to direct towards the battery and one with the switch and towards the battery as shown here. This is the setup that I'm talking about. Okay, right? Then later, now switch on the battery so that the current flows. You can find that in this test tubes you can find small bubbles. You can find the bubbles, and these bubbles are nothing but the bubbles of oxygen, containing oxygen. So here the reaction that took place is that the water is getting decomposed into its separate elements H2 and O2. In order to balance this equation, it will become 2H2O, 2H2. So this is a decomposition reaction where one reactant is giving rise to two products. This activity 1.8 says that silver chloride should be taken in the presence of sunlight. In the presence of sunlight we are using this, we are making this activity. So the silver chloride is getting decomposed into silver and chlorine in the presence of sunlight. You will see that the white silver chloride turns gray in sunlight. This is because due to the decomposition of the silver chloride into silver and chlorine by light. Okay, so initially the white colored silver chloride turns into gray in the presence of sunlight. So silver bromide also decomposes in the same way, like into Ag and bromine, that is silver and bromine gas in the presence of sunlight. The above reactions are used in black and white photography, that is the reactions of silver chloride and the reactions of silver bromide. We use them in photographies, in black and white photographies, like in our olden days we use these reactions. We have seen the decomposition reactions require energy either in the form of heat or light or electricity. So what are the examples for heat? We have seen that the decomposition of lead nitrate required heat. For light, it is nothing but the silver bromide, silver chloride. For electricity, it is water. So, in order to make a decomposition reaction, we have some catalyst like substances, that is heat, light or electricity are required for breaking down the reactants in order to proceed, like in order to help the decomposition reaction we need either heat, light or electricity. Reactions in which energy is absorbed is called as the endothermic reaction, that is here heat is absorbed to break the reactant, light is absorbed to break the reactant, electricity is absorbed to break the reactant. So as these reactions are said to be the endothermic reactions. We have learnt about exothermic reactions while we are discussing about the combination reactions. What is that? That is when the heat energy is released, not only heat energy, when the energy is released we call it as exothermic. When the energy is absorbed we call it an endothermic reaction. So this is about the endothermic reaction and about the decomposition reactions.